A permutation. A permutation is an ordered arrangement of a set of objects. So, order matters. So, just a little talk about what a permutation is. Now, suppose I have three numbers, and I am going to arrange these numbers. So, how many different choices are there to make for the first number? Well, there's 3. And there's 2 for the second one. So there's going to be a total of 6 possible different arrangements of these 3 numbers. However, what a combination is, so order does matter. So for instance, 39 is different than 93. The order of the 3 in the tens place makes a difference. Whereas a combination, 3 and 9 and 9 and 3 are indistinguishable. That is that they're the same entity. We'll get to that a little bit later on, but that's a combination. Also, in reality, I'm just going to draw, by the way, this is a combination lock. And by the way, it's incorrectly named as a combination lock. Now, I'm just going to write down my combination. There's my combination. But it's actually not a combination, it's a permutation. Because order matters. Your first number has to be 21. And then after 21, you have to turn the dial, and then it has to be 31. And then you have to turn the dial and enter 23. That's a permutation. Order matters. Combination would be, if a combination lock, you could enter this, or 21, 37, and 23. Order wouldn't matter of your objects. Anyways, that was a long ramble, but that's a permutation and combination. So a permutation, I'm going to get down to the notation of a permutation. NPR represents a number of unique arrangement if R distinct objects are taken from a set of N distinct objects. We have been doing this before. So, and it really makes sense if we talk about it in terms of a set. So here, in our earlier example, if I have 6 letters, those are 6 distinct objects, right? Now, they're distinct because they are different. Now, if I'm going to choose a subset of them, that would be R distinct objects. So if I'm choosing is again a loaded word in math, if I'm selecting objects, this will be a permutation. So, but order matters. How many different words can be made if 3 letters are selected from 10 distinct letters? So here I don't no longer need to write out 10 distinct letters. Here I am selecting 10 out of 10, 3 letters, 10p3. And my calculator has this function available to me. Now, I'm going to move on to the next question. How many different ways can 3 books be arranged on a shelf if they are selected from a box of 10 books? Now, presumably, the order of the books will matter. That is, I'm going to assume that A, B, C is going to be different than C, B, A. So again, out of 10 possible ones, I'm going to find the number out of a total set of 10. I am going to select a subset of 3 of those. So they can be arranged in this. And we could write this as 10 factorial divided by 10 minus 3 factorial. And this is 10 factorial over 7 factorial. And there we have it. I'm going crazy. And then we reach this golden 7 factorial, and we're able to cross out those common factors, and what we're able to see, I believe that's 720. But your calculator also has this function, p. If you go into your math button again, and in the probability, so you hit the math button, in probability, it is the second option that says NPR. That will be it. All right. Let's get on to the next question. Suppose you have a class of 30 students in which a class president, a vice president, an accountant, and a social representative must be chosen. How many different arrangements are there for these positions? So right now is I have a class of 30. I have a set of 30 students. Now, there's no possible way that I wish to write out 30 positions, but I'm going to choose an arrangement of presidents, vice presidents, an accountant, and a social representative. So I'm choosing 4 positions. And those 4 positions, order does matter. How many possible different arrangements? Well, it's 30p4. And you can do that in your calculator, 30p4, and that is 657,720 arrangements. That is one way using this notation. What I'm going to choose to do now is I'm going to just say, use my fundamental counting principle. I need to choose 4. For the president, there are 30 choices. For the vice president, there are 29 choices. For the accountant, there are 28 choices. And for the social representative, there's 27 choices. Now, if I know my math correctly, those 2 numbers should be equal. All right. We're going to evaluate 7p2 using factorial notation without a calculator. So 7p2, now just to recall that NPR is going to be equal to n factorial divided by n minus r factorial. So really this is 7 factorial divided by 7 minus 2 factorial. And this is going to be 7 factorial divided by 5 factorial. 7 factorial divided by 5 factorial is going to be equal to 7 factorial is I'm going to start breaking this down into factors. 7 times 6 times 5 times 4 times 3. But really,